All right, so we're looking at an example problem here on page 8 of the packet. It's the firemen, putting out a fire. So let's read the question quick. Firemen are shooting a stream of water at a burning building. A high pressure hose shoots out the water with a speed of 25 meters per second as it leaves the hose nozzle. Once it leaves the hose, the water moves in projectile motion, meaning we can ignore air resistance. The firemen adjust the angle of elevation of the hose until the water takes 3 seconds to reach the building 45 meters away. You can ignore air resistance. I knew that already. Assume that the end of the hose is at ground level. Okay. And find the angle of elevation of the hose. And also, how high above the ground does the water strike the building, and how fast is it moving just before it hits the building? Okay, so I want to first kind of figure out what angle do I have here? Okay, so let's think about our problem type. So it's going to be moving both in the X and in the Y because we fired it at an angle. And so I list my two sets of variables. They told me projectile motion. They also said ignore air resistance. So the only thing acting on is gravity. So all of my acceleration is in the Y direction. So projectile motion, I fill that out in blue here. Angled launch, so I need to resolve the initial velocity into components. Even though I don't know the angle, I still resolve it and just leave that variable in there, okay? Because that's the variable I'm going to end up solving for. And they told me the time. How cool is that? If they give you time, that's kind of a nice one here, especially when we have different ending and starting heights. All right, so let's go ahead and see what happens when we plug in our information here. So I know it ends 45 meters away, so where is this theta? Well, this theta is inside that V naught x. So I have x is equal to V naught cosine of theta times t. So I'm solving for that theta in there. Okay, so let's go ahead and do that. So we're going to divide the t over and the V naught over. So now I have x divided by V naught times t equals the cosine of theta. And the last thing I need to do to get theta by itself is to take the inverse cosine. So I find out theta is equal to the inverse, nice if I write inverse cosine there. The inverse cosine of x, which was 45, divided by V naught t. So I have V naught was 25 and t was 3. So I plug that in my calculator, I get 53 degrees or 53.1 degrees. Go ahead, store that in your calculator because we are going to need to use that theta value over here in the Y direction. So we're going to want to store that number. So hit the STO button right above the on key and then choose a letter like X or A or something like that. Okay? All right, moving on. We want to find the height that it reaches the building at. Okay, in order to find the height it reaches the building at, we are trying to find Y. We do know theta now. We know this is the 53 degrees. So I want to find y, but I don't know Vy, so I'm going to pick an equation without V final. That would be equation number 2. So I have y is equal to y naught plus V naught yt plus 1/2 ayt squared. They say it starts on the ground. A little odd, but that's okay. And then we just have to solve for y here. So we have 25 times the sine of our 53 number we stored, times our time, which was 3, plus 1/2 times negative 9.8 times 3 squared. And so y equals, plug that in my calculator, I end up with 15.9 meters above the ground level. Now, in order to solve for the final vertical velocity, or the final velocity, I'm sorry, I need to find both the x and the y components of that velocity. Okay, so let me go ahead and erase a little bit here and we'll start up. All right, so we got this set up. Now we're going to find these two final velocity components and put them together. So the final vertical velocity final horizontal velocity is the same as the initial. So Vx is going to be our 25 times the cosine of our 53 that we stored on our calculator. Now, if you stored that properly, when you type this in, you should get 12 meters per second. So my horizontal velocity component is positive 12 meters per second. Now to find my y component, so I start plugging this information in. So I have V naught y, so I have 25 sine of 53 plus negative 9.8 times 3 gives me a vertical velocity of negative 9.4 meters per second. So in order to find the final velocity of that water, I need to go ahead and do the Pythagorean theorem here and figure out what is the magnitude and what is the angle. Okay, so to find the magnitude, we need to take the square root, 12 squared plus 9.4 squared, and we get something like 15.3? 15.2 meters per second. To find the angle, I need to take the inverse tangent of the opposite side, 9.4, divided by the adjacent side, 12. And you end up with an angle of roughly 38 degrees. And so I have 15.2 meters per second at 38 degrees below the horizontal. Don't forget to include that reference on your direction. So there's our example.